Welcome to our lecture on prototyping and testing. Today we will explore various methods used to bring ideas to life and evaluate their effectiveness. We will cover, understand the various methods of prototyping, explain and apply role-playing methods, utilize storytelling techniques in the prototyping process, plan and conduct effective prototype testing sessions, identify key considerations for recording and analyzing testing outcomes, apply various methods for eliciting user feedback during and after prototype testing. By the end of this lecture, you will have a comprehensive understanding of prototyping and testing methods, enabling you to create more effective user-centered outcomes. Let's begin. In this lecture, we'll explore prototyping and testing through three key stages: thinking, making, and testing. First, we'll examine the thinking stage, focusing on physical interaction, immersion, and movement in design conceptualization. We'll discuss role-playing methods like body storming and empathic modeling. Next, we will cover the making stage, exploring various prototyping approaches such as paper prototypes, form prototypes, behavioral prototypes, and functional prototypes. We will also touch on storytelling techniques in prototyping, including Lego serious play. Finally, we will address the testing stage, discussing how to plan and conduct effective prototype testing sessions, as well as recording and analyzing outcomes. This structure will provide a comprehensive overview of prototyping and testing process, from initial concept to final evaluation. Let's begin with the thinking stage. Thinking happens from the beginning of a project, but in this context, I will talk about thinking relating to prototyping. By this, I mean thinking through physical interaction, immersion, and movement. This is broadly referred to as role-playing, where people participating in the project act out the roles of users or stakeholders to explore interactions and behaviors in real-world scenarios. With this approach, prototyping can begin before physical representations are created to understand design problems. Two specific methods of role-playing and body storming and empathic modeling. Body storming is an immersive technique where participants physically act out scenarios in environment or context where a design solution will be used. This enables the exploration and testing of ideas. After defining a specific user scenario or problem, participants physically act out the situation using props or mock-ups as needed. This could be low-fidelity prototypes already created. Participants can assume the role of users, stakeholder, or objects and technology in the context. Creativity is important. Body storming is effective early on in the ideation and later in the prototyping phases. It effectively explores how a design solution might be used in a real-world context. Empathic modeling involves simulating the experiences of users, particularly those with physical or cognitive limitations, to better understand their challenges and needs. This might involve wearing gloves to reduce dexterity, using glasses that impairs vision, or restricting mobility in different ways. Empathic modeling is useful early on as it can inform design development. It might involve testing current products or systems to understand how they fall short of users' abilities and expectations. Role-playing method builds empathy by experiencing situations, products, and systems from other people's perspectives. They allow tangible exploration of ideas, help uncover usability challenges early, and encourage collaborative problem solving. It is important to document outcomes, the feelings, challenges, and observations, so they can be inserted into the design process. More traditionally associated with prototyping is making. If you remember in the previous lecture, you learned about different types of prototypes, low fidelity and high fidelity, and looks like and works like. These different types translate to different approaches to making. There are many approaches to make, but I will provide an overview of the common approaches over the next few slides. Paper prototypes. often referred to as wireframes, are a low-fidelity approach to prototyping, where simple, hand-drawn sketches or cut-out elements are used to simulate interface or product designs. One of their benefits is that they are quick and easy to make. Simply sketch out what you are prototyping on paper. It could be screens of an app or website, pages, or component of a physical object. These elements can be cut out so they can be reordered. Cutouts can also be used to represent buttons and other interactive elements. Elements can be arranged in a way that encourages interaction from users or stakeholders. When interactions are made, the designers can reorder or swap out elements in a way that simulate how the product or system works. This allows parts of a product or system to be tested without much time investment. As you can imagine, paper prototyping is effective early on in the prototyping stage, when concepts need to be tested quickly and inexpensively before committing to higher fidelity representation. Form prototypes, also known as mockups, focus on exploring the shape, size, and ergonomic of product or system without necessarily addressing its functionality. To create a form prototype, it is important to use materials that represent the part of the form being explored. For example, if it is a digital product, using digital tools to create the prototype is most appropriate. If it is a 3D object, materials such as cardboard, foam, or 3D printing could be used, depending on the fidelity explored. Form prototypes allow exploration and assessment of physical attributes such as size, weight, and visual appearances. Gaining perception on these attributes can answer important questions about the suitability of the design for given context or user, how people respond to the aesthetic characteristic of the design. Exploring forms at a high fidelity also inform the usability and visibility of design features. Form prototyping is often used in the middle stages of prototyping once some of the basic elements of the intended design are worked out. Behavioral prototypes, also known as interaction prototypes, are used to explore how users interact with and respond to a product or system by simulating functionality and features. Behavioral prototypes can involve low fidelity and high fidelity representations. The important thing is that these representations mimic interactions and functionality. There are digital platforms that can help achieve this interactivity, or the interactivity can be faked by the designer, such as by rearranging prototypes and swapping out elements to respond to user interactions. Regardless of the approach, users should be given specific scenarios or tasks that they can role-play when interacting with the system. This helps to understand how people respond to real-world scenarios and use cases when interacting with the prototype. Behavioral prototypes are effective in the later stages of design process, when functionality and user interactions need to be tested before final development. Functional prototypes are high-fidelity prototypes that closely represent the final design, both in form and function. Because of this, functional prototypes blend many aspects of other types of prototypes, form and behavioral, for example. They are typically used late in the design and prototyping process to simulate the final design's behavior and allow users to interact with it as they would with the finished design. They are important to ensure the final design meets the needs of the users in the context intended for use. Storytelling is a powerful tool for communicating ideas. People are much better at understanding and remembering stories than a set of facts or information. Stories allow us to bring together many ideas into a single cohesive narrative, and emotions, people, fact, events, outcomes, and so on. In the context of prototyping, storytelling is a narrative-based technique that uses stories, scenarios, or visual storytelling to explore users' interactions with product or system. There are various ways to do storytelling prototyping, such as through written stories, storyboards, video recording, and so on. One specific method I'll focus on is Lego Serious Play. Participants use Lego bricks to build 3D representations of ideas, situations, challenges, or solutions. It is a collaborative process where many people can contribute. Once representations are constructed, participants share and explain their creations. This might involve acting out the situations or scenario with characters engaging with the Lego model. The intention is to foster dialogue and reflection. This method combines physical making with the storytelling to tap into diverse perspectives and insights. Lego serious play is fantastic during the early ideation or problem-solving phases, particularly when teams need to foster creativity, encourage collaboration, or break down complex challenges. Because of how accessible Lego is, it is suitable for participants of all kinds. Over the last few slides, I will discuss testing. Testing and prototyping go hand in hand because prototypes are made and intended for testing and improving ideas. Testing usually involves getting a user, or as close as possible to a user, to interact with the prototype. Depending on the prototype and the aim of the testing, this could be to elicit feelings such as like and dislike, meanings and associations, identify pain points like problems, confusions, confirm tangible details, for example, proportion, size, location, function, compare options such as A/B testing, concept evaluation, small variations, develop insights like new opportunities and new directions. Let's talk about some considerations when testing. This involves knowing what is being tested and what type of information is desired from testing. This planning should start before making a prototype so that the design of the prototypes is fit for a specific purpose. Things to consider are what variables should be explored, such as different users with different abilities. Assumptions, what do you think will work or not work, and how can you test this? Questions, such as, are there specific questions you want to find answers to, including questions to ask users? Criteria. What type of criteria will you evaluate the testing outcomes against? Usability, complexity, efficiency. Another planning factor is how testing outcomes will be recorded. Will testing occur in a naturalistic context or in a controlled environment? What equipment is needed? Will it be video or audio recorded? What type of notes will be recorded or taken? When conducting testing, it is useful to have specific tasks to complete. These should align with the plan and purpose of the prototype, as well as the information desired. Setting realistic tasks can help guide testing to address specific assumptions. The task and testing goal should align, and tasks should tell a user what to do, not how to do it. For example, ask to create a new account and add a picture, rather than listing the steps. It can be beneficial to get the person testing the prototype to think aloud while they're using the prototype. This involves the participant explaining their decision-making process and other thoughts verbally. To encourage this, provide simple prompts and ask questions during testing. For example, what do you think of that? Or what did you expect to happen? Finally, recording testing outcomes. Consider what exactly should be recorded. A lot happens in real time. Some events will be important and other events won't be. Reactions during testing can be fleeting and impermanent. How can these be captured if they're important? Behaviors, actions, and workflow when using a prototype. Facial expression, gesture, body language, etc. Depending on what is needed, it is useful to consider video recording or having additional testing facilitators to keep detailed notes. Outcomes can also be recorded retrospectively. This often occurs in the form of an interview or conversation after the testing has been completed. This often occurs in the form of an interview or conversation after the testing has been completed. Questions should achieve the testing goals and create an open dialogue. For example, how might you use this in your daily life? Can you describe your experience with the design? Can you tell me about the features you like or dislike most? It is useful to keep the prototype nearby during retrospective sessions so that the participant can engage with it or refer to it as needed. In this lecture, we covered understanding the various methods of prototyping. We have explained how to apply role-playing methods, utilize a storytelling technique in the prototyping process, Plan and conduct effective prototype testing sessions. Identify key considerations for recording and analyzing testing outcomes. Apply various methods for elicit user feedback during and after prototype testing.